Hello, everyone. Good afternoon.
Oh,
Hello.
How's everybody doing today?
Professor. Good.
All right, welcome back, everybody. We'll just give folks a few seconds here to get logged in. Okay, I think I'll get started here. All right, so welcome back, everyone. I hope you had a nice weekend. The weather was pretty moderate this past weekend, so get outside and enjoy it if you have the opportunity. And congratulations on getting past your first lecture exam of the semester. Having a class average of 77% is not a bad start to the semester. Okay, we did have folks in basically every grade category from A through, unfortunately, some Fs as well. Okay, so if you want to come talk to me about your exam, during office hours, I would be more than happy to go through your exam with you and answer any questions you might have about how the exam was set up, how it was graded. Okay, so you are welcome to do that. Okay, hold on a sec while I need to read a chat message. Okay, Tiffany, I understand. I have read your message and I understand. My condolences. Okay. It's okay. All right. Okay, folks. So if you had a chance to take a look at your email this morning, you would have noticed that I did send out an email. If you haven't checked it, go ahead and check it right now. Go ahead and check it right now. What you're going to find is the following. Okay, I'm going to share my screen with you here. Okay. All right. So what you're going to find is this workbook that was attached to your email this morning. I understand, Kit, no problem. Okay. So this workbook is in your email from today, and I want to encourage you, to save it to your computer, right? Download it and save it on your hard drive of your device, your computer, and have it accessible as a resource for microbiology. Okay. This is a workbook which has a variety of things in it that we will be using throughout the semester. Okay. And so let me just walk you through what the workbook has in it. And then afterwards, we'll get down to business of what we're going to achieve today. Okay. So, I always put this little, hopefully funny looking graphic up here, never give up, because I know for many students that math is sort of an anxiety building kind of topic. Okay. And I don't want it to be. We still want to build your mathematical skills up so that you can analyze data, because what do scientists do? They analyze data. Okay. So we're going to try to build you up a little bit in this course and apply some basic skills to the analysis of microbiology data. That's where we're headed with this. Okay. And so on the front page, we have some unit conversion information, which I'll talk more about in just a moment. The next page, I have an example of how various numbers are written. For some of you, I know you said that you're just not really familiar with scientific notation. So I give this illustration of how, a decimal value of a number represents a fractional value, which is the same thing as a scientific notation value. Okay, we'll go through this in just a moment. I have an example page here where I literally go through step by step how you do unit conversions, and that's something that I'm going to talk about with you today. Okay. Then I have some unit conversion practice problems, which after lecture today, I will be assigning to you as homework. Okay. And then there's some additional assignments that I'm not going to assign today, but at some point in the weeks ahead of our semester, I will be assigning, and it typically involves some graphic data analysis of microbiology data. Okay, things that we want you to get comfortable with looking and interpreting scientific data that is represented graphically to you. Okay, Samantha, go ahead.
I just had a question. Are we going to be allowed to use the workbook like for tests?
Okay. Um, so, on your second exam, which is obviously weeks away yet, there will be some unit conversion problems. And again, if you were sitting in a physical classroom with me, the answer is no, you would not be allowed to use the workbook. Okay, the workbook, you would not be able to access the workbook during an exam. Okay. Now, that being said, again, I cannot stop you from doing things and looking at things while you're sitting at home, and I'm not going to make an attempt to do that. That being said, there are certain pieces of information in the workbook that would be beneficial to you as a future nurse or future whatever you're going to be, to actually memorize these things because it will benefit you in your work life in the future. So Samantha, I would prefer if you did not access the workbook, but I can't stop you. Okay.
Okay, thank you.
Okay. Other questions? Okay. So let me just say at this point that, today what we are going to do is go over the process of converting between units. Okay, that's what we're going to explain today. That's what I'm going to go through today with you. And in terms of the additional assignments 2, 3, and 4, those are things we're not going to talk about today. We'll talk about them later. And I'm actually going to ask you to please not work ahead. Please do not work ahead in the workbook, because that kind of ruins some class activities that I have. So I'm going to ask you to please not work ahead and just do the assignments at the pace that I'm asking you to do those things. Okay. So for right now, we're going to be looking today, we're going to be looking at everything from pages 2 through 5 in our conversation of what we will be doing. Okay. So any questions, any problems? Did everybody get that email okay with the document in?
Yes.
Okay.
Yep.
All right. So let me ask you another question, and I'm going to momentarily stop sharing my screen here and just have a conversation with you. Let me ask this question in the chat window. And if any of you can contribute a response, I would appreciate, unmute your microphone and contribute to the conversation here. My question might be a little odd, but I want you to think about it for a moment. Here we go. Are you aware of any news stories you have heard of where a situation, where a problem or situation, excuse my language here, where a problem or situation occurred because of a math error? Are you aware of any circumstance that had perhaps a tragic or difficult or frightening outcome because of a math mistake? Okay. Would you be willing to share that, Taylor?
Yeah, it was the Millennium Bridge in London, where they didn't account for a lateral movement when people were walking on the bridge. And so it made the bridge dangerous, and they had to shut it down and kind of add force absorbers to stop it from swaying.
Okay. Thanks for sharing that, Taylor. That's one I had not heard of. So I really appreciate you sharing that. Okay. Any other stories that, you don't have, this is just a time of sharing. If you've heard of a story or aware of something, please feel free to unmic and to unmute and just speak out. Anybody? Kit, did you want to say something? Okay, all right. Well, let me tell you a few stories. Some stories that involve errors of converting incorrectly between units, because that's our topic of conversation for at least the first half of our class today is, how do you change from one unit to another unit? And why does it even matter, right? Who cares? But it is a big, big deal. So let me just, before I start, let me draw your attention to Kit's comment in the chat window. It's actually got to do with the patient's meds, so I can't share details. Okay, Kit, fine, thank you very much. And the truth of the matter is that every day across the globe in hospitals around the world, there is some patient that's getting an incorrect medication dosage because of, a mathematics mistake of one form or the other. That's happening every day. I mean, that's one of many reasons people are absolutely terrified to go to the hospital, right? Because they know mistakes happen and you might come out worse than you went in, okay? So people are scared. So patient medication is a very common one. Let me share some other stories with you. I'm just going to read off a piece of paper that I have here. Okay. And, so some of my stories are before many of you were even born. Okay. On September 23rd, 1999, NASA lost the $125 million Mars Climate Orbiter spacecraft after a 286-day journey to Mars. Miscalculations due to the use of English units instead of metric units sent the craft slowly off course a total of 60 miles. Thrusters used to help point the spacecraft had, over the course of months, been fired incorrectly because data used to control the wheels were calculated in incorrect units. Lockheed Martin, which was performing the calculations, was sending thruster data in the English units of pounds to NASA, while NASA's navigation team was expecting metric units in newtons. Okay, so, and let me read the first statement again. NASA lost the $125 million Mars climate spacecraft. In other words, in 1999, the United States taxpayers had $125 million of their money go down the proverbial toilet because two agencies involved in the project could not communicate correctly in terms of their usage of units. It's a big deal, but it's silly, but it's thank God nobody lost their life over that. Okay, here's another one. January 26th, 2004, Tokyo Disneyland Space Mountain. An axle broke on a roller coaster ride, on a roller coaster train mid-ride, causing it to derail. The cause was a part being the wrong size due to a conversion of the master plans in 1995 from English units to metric units. In 2002, new axles were mistakenly ordered using the pre-1995 English specifications instead of the current metric specifications. Okay, so that, I had to look up the outcome of that. Even though the train did derail, fortunately, there were no deaths associated with that accident. But you can bet it scared the heck out of everybody, and it could have definitely led in fatalities. Here's the third story. July 23rd, 1983, Air Canada Flight 143 completely ran out of fuel about halfway through its flight from Montreal to Edmonton. The fuel loading was miscalculated through a misunderstanding of the recently adopted metric system. For the trip, the pilot calculated a fuel requirement of 22,300 kilograms. There were 7,682 liters already in the tanks. Okay, so again, unit conversion issues, a failure of people to communicate. This is typically what ends up being the cause of serious issues. There was another story, and I don't remember the exact date. This might be going back 12, 15 years, where there was going to be a polo match between the United States polo team and an Argentinian team. So this was going to take place in the United States. So I believe the Argentinian team had traveled with their horses to Florida to get ready for this polo match. And apparently in Argentina, they like to give their horses some kind of sports drink, kind of like Gatorade for horses, if you will. Well, they didn't have the drink available to them in the United States, so they hired a compounding pharmacy to actually prepare this sports drink for the horses. And long story short, the compounding agency prepared the sports drink incorrectly. They made it wrong. When the sports drink was given to all the horses on the polo team, it killed all the horses. Okay, so there are big issues with getting things that we don't like to pay attention to wrong. And Kit's comment about patients' medications is really at the top of my list, thinking about where many of you are headed with your future careers in medicine, that a unit conversion error on a drug dosing calculation could be life-threatening to your patient. You know, if you give your patient too little medication, at least you're not going to kill him or her, but that the medication is not going to really have any therapeutic value. It's not going to help them. If you err on the other side and you give more than you thought you were giving, then obviously you could harm that patient, kill that patient, open yourself up to legal liability. Okay, so I have a question for you that you may or may not know the answer to, but it's just something you should think of since you are a hack student. And just give me a moment to phrase this question. Here we go. If you are in the hack nursing program, when you take your drug dosing exam, how many questions are you allowed to get wrong and still pass the exam? What do you think, folks? How many questions are you allowed to get wrong and still pass the exam? Okay. Yeah. The answer is, as you surmise, it is 0. You are not allowed to get any of it wrong, because the outcome, the implications for it could be such devastating consequences for another human being, right? So that's not to scare you. That's just to say you got to take this really seriously, okay? Really seriously. So what we're going to do today is teach you the process of converting between units, okay? It's something that is easy to do as long as you follow a logical process, okay? So let me share my screen with you again. Let's see here. Yeah, okay. Let's first talk about entering numbers. Let's first talk about entering scientific notation values into your calculator. Okay, I hope you have your calculator available. I ask that you do please have it available for today. So if it's next to you, get it out, look at it, dust it off, take a look at your calculator. Okay, and so obviously you all have different calculators, and so it's going to be hard for me to know what kind of calculator you have. But the first thing we need to do is we need to identify our scientific notation key. Okay, so let me give you some examples of scientific notation keys on calculators, okay? And what I'm going to do is bring up some images here of calculators on this is a Bing actually. And let's see what we can do here. Okay, so let's bring up this one here first. Okay, so hopefully you can see this. On this sharp version of the calculator, here is the scientific notation key. It's EXP. EXP is the scientific notation button on this brand of calculator. Okay, so that's one possibility. Okay, so one possibility is an EXP key. Another possibility, let's take a look at other things. Okay, let's see here. We have a Casio. Let's take a look at the Casio. Well, I can already see what that is, right? Take a look, there's the EXP button. So you might have an EXP button on yours, okay? Okay, so Tiffany, you're using a Texas Instrument. So let's take a look at a Texas Instrument. Texas Instrument often has capital E, capital E. And that actually stands for engineering exponent. So see if you have a capital E button. Okay. So let me note that on our example here, capital E is another one. Okay.
On the TI-84 plus, guys, it's like a second for the comma.
Thank you for sharing that. Thank you for saying that. Absolutely. Yep. There are, okay, as you have noted, some calculators you have to push a second button and then another button to get your EE going, right? So I'm going to ask you to see if you can find your scientific notation calculator key. Let me see if there's any more here. Here's another one that I have come across in time, and it's this times 10 to the n or something like that, times 10 to the n. Okay, so just see if you can find your calculator's scientific notation key. Okay, folks, if you cannot find your calculator's scientific notation key, please speak up. Okay, so here's what I want you to do, with your calculator, turn your calculator on, okay? And what I want you to do, okay, Afala Shadi, what kind of calculator do you have? Oh, Casio 115 ES Plus. Let's see if we can find it. Okay. Do you see it on the screen right now, Afala Shadi? Can you see it right now? Does it look like this?
Yes.
Okay. Let's see if I can bring this up here. Sorry, I don't have enough screen real estate here. There it is, times 10 to the x at the bottom row, times 10 to the x at the bottom row. Do you see it, Afala Shadi?
Yes, thank you.
Okay, great. Anybody else having trouble?
So just asking for the sorry, Dr. Allen, the individuals that answered me on the T85 TI-84 plus. So we also have the option of using the second log. Would that be an option as well?
I'm sorry, the second what?
On the TI-84 plus, there's also, we can go second and then log, LOG. Would that be on the same?
Okay, hold on a
It has
second.
like a 10x. Like a 10 with the X to the, like, exponent?
Okay, let me look at this. Let's see if we can bring it up on Amazon. I think you're probably right. Okay, come on. There we go. Is this one what yours looks like, Elena?
It's not, that's the plus CE. I don't have that one. I just have the TI 84 plus. It's a Texas Instrument.
Okay. Does yours have
Right
like
there.
a blue second key?
Yes,
And
it
then
does.
and then a blue EE?
If I use the option of second comma, I have the EE, but I also, the one right here, the one kind of diagonally bottom to it, that's what I was asking.
With the log button? No, you do
Yes.
not want to do that. You do not
Okay.
want to do that. Okay.
Okay.
Thanks for asking.
All right, thanks.
All right. So much easier if we're together. Any other problems? Okay, so what I would like you all to do is go ahead and type in, and I'm going to use my calculator on the screen here. So just follow after me with your calculator. Type in 1, then press your scientific notation key, whatever it is, EXP on my screen, and then hit the number 3. So I put in 1, then I hit my scientific notation key, then I hit the number 3, then I want to do equal. Type into the chat window what you get. What I'm hoping and what I'm fishing for is that you do come up with 1,000. So was anybody unsuccessful at that?
Yeah, I got 1 point times 1003 exponent.
1 point times 10 to the 3. What kind of calculator do you have?
I have the Texas Instrument TI-30X IIS.
Okay. That would be okay. It's mathematically equivalent. And what I'm telling you is that for whatever reason, your particular calculator has been programmed by the people that wrote the software for the calculator, has been programmed, Yasmin, to simply represent your number that way. And that is okay. That's
Okay,
fine.
so I could write that down and still be correct.
Yes.
Okay.
Okay. Now, for the benefit of others, and you can do this also, Yasmin, let's see what happens. Okay, so clear that entry out.
Mm-hmm.
And now what I would like you to do is to put in 1, then press your scientific notation key, then hit the number 3, and then there should be a plus minus symbol. You want to change the exponent to a -3. Change the exponent to a -3, and then hit equal. What do you get? Please type into the chat window.
Lost me there.
Okay, let's do it again. Okay, let me make this really big. Okay, what I want you to do is, with a clear screen, press the number 1, then press your scientific notation key. For you, Elena, it would be that second and then the little EE. Then press the number 3.
Okay.
And then there should be a key on your keyboard that allows you to change the sign of the number 3 to a negative number. Try to do that and hit equal. What do you come up with in the chat window? Okay. It should be coming up 0.001.
1. Yep.
I can't figure that out, how to do that, the negative.
You can't figure out how to do the negative. Okay. Let's
on
take
the-
a look. Let's take a look here. So I'm just going to look at this calculator. Hopefully it's similar enough to your calculator. Okay. Anybody else have a TI that they can help Elena with?
Yes, I have a TI.
Can you-
So the
Go ahead.
one I press is right there, that little sign where it says A and S.
The negative
And
in
then
the parentheses.
Yeah, the negative
Okay.
in parentheses. That's the one I used.
I had to put,
But
like-
the negative is the dash is behind the 3.
No, put it before, because when I put it after, I got the error syntax. So then I did it again and put the negative before the 3 and got 0.001.
Yeah, that's what was confusing me, because the way you explained it, Dr. Allen, I was kind of following exactly your steps.
Right. And you understand that the steps are different for different calculators. That's why, you know, there's no universal correct. You have to adapt to your specific calculator. So for yours, you need to put in 1 scientific notation -3. Is that what I'm getting?
It kind of like, yeah, like it'll show up negative on there, but it has to be done before you enter the number.
That's fine. That's fine.
Thank you.
You're welcome. Okay. So is everybody okay right now that you could type in 1 times 10 to the +3 and get 1,000 out, and you can type in 1 times 10 to the -3 and get 0.001 back out.
Yes.
Okay. All right, folks. If you can do that with your calculator, you basically have all the skills you need at this point to do the mechanical aspects of number crunching that you will be asked on exam 2. It's really that simple. In other words, you want to get familiar with your own personal calculator. And as Elena's question revealed, different calculators from different companies are programmed to accept input slightly differently than others, which means there's no universal way to do it all the time. You got to get comfortable with your calculator so that you can do it correctly. If you do have any troubles with that, you continue to have a problem, pop in and see me during office hours. If I can give you more one-on-one, then we can definitely solve those problems together, okay? Do you have any questions before we continue?
None.
Okay, all right.
No, I'm okay now. And thank
Great.
you for whoever answered to help me with this.
Absolutely. Thanks, everybody, for contributing. That's what we need today. Okay, so if you can do that, now we can move on to the other aspects of the unit conversion work. Okay, so let me get this up here. Okay. All right, so, you know, for those of you that have had chemistry, you probably know exactly what I'm talking about, because unit conversion is a topic that is taught very early in most undergraduate chemistry sequences. Unfortunately, we do not have the circumstance at HAC that everybody taking microbiology has had chemistry. I cannot make the assumption that you know how to convert between units. And as your anxiety from some of the math stuff in lab is suggesting to me, some of you are rusty at this. If you, and maybe you have never been exposed to this. Okay. So unit conversion is the process of taking one unit and changing it into another. It's really that simple. But how do you do it? First off, you need to know your conversion factors. Okay. In medicine, in the scientific application of medicine, well, let me ask it this way. Okay. And I bet you I might get some different answers, but let's see what happens here. When you are weighed at your doctor's office, is your weight reported as kilograms or pounds? Okay, so I would say at my doctor's office, they always write it down as kilograms, but you know, since we live in America, everybody thinks about pounds. So it's the imperial units from good old King of England from eons ago. Okay, the point of it is that modern medicine has adopted the metric system, okay? And so the metric system deals with things like length, which is described in meters, mass, which is described in grams, volume, which is described in liter units, okay? Most of you don't have that experience because you've been raised in the United States, and so you're used to thinking about miles, you're used to thinking about pounds, okay? You're used to thinking about inches. You're not used to thinking in typical metric units, okay? And so this is going to be a little bit foreign to you, but it is extremely doable. This can be learned, is what I'm trying to get you to say, okay? So let's start here in your notes, okay? Comparisons between the English imperial units that you are most likely used to and the more accepted SI, which is System International, which is basically the same thing as metric units, okay? So let me give you a couple examples here, okay? In the chat window, and I think I've asked this before, in the chat window, okay, how many inches are in 1 meter? How many inches are in 1 meter? Do you know that off the top of your head? Okay, I'll take Rachel and Morgan. Thanks so much for your response. I deeply appreciate it. And you know, that is what most people say, and it's just not right. Okay, it's not 36, it's 39 point something. Okay, so the point is that, you know, and not picking on Rachel or Morgan, but you just reported what a yard is, not what a meter is. Okay, so 1 meter is equivalent to about 39 inches. It's 39 point something, but I'll just round it down for right now. 1 meter is 39 inches. So if you can imagine taking the yardstick you might have at your house in your closet that you use to measure things, take your 36-inch long stick, add 3 more inches to it, 39 inches, you now have 1 meter. That's a traditional unit of length in the metric system, right? This is when we're dealing with length here. All right, let's try this one. Let's try this one in the chat window, if you know it, and if you don't, it's okay. How many liters are in 1 gallon? How many liters are in 1 gallon? Okay, four is a pretty good approximation. It's not, you know, super accurate, but it's a pretty good approximation. The answer is closer to 3.79 liters. Okay, so we have 3.79 liters being equal to 1 gallon. And think about it. When's the last time you stopped at the supermarket, Giant Wise, wherever you folks shop? When's the last time you went to the supermarket and you picked up 3.79 liters of milk? I mean, we don't typically think of it like that, right? At least I don't. I grew up in the United States. My wife tells me to go get a gallon of milk. I go get a gallon of milk. I don't get 3.79 liters of milk. Okay, we're just not used to that. All right, so liters would be a unit of volume, right? And then here's one more, and then we'll move on for it. How many grams are in 1 pound? How many grams are in 1 pound? Just tell me if you know, and if you don't know, I mean, I know you can all Google it, but if you happen to know, just type it in there. It's not something we typically think about, probably. Okay, so all right. Thanks everybody that are providing the answer here, right? It's about 453.6 grams, right? 453.6 grams is roughly equal to 1 pound. Okay. So when is the last time, you know, you picked up one? Now, when is the last time you went to the supermarket to get some some hamburger meat to grill up some nice burgers for a holiday, and your spouse asks you, oh, please go to the supermarket and pick up 453.6 grams of meat. No, you say, hey, go pick me up a pound of hamburger, right? So our life's experience has not traditionally been in the units that science and medicine is interested in measuring things in, and we need to get more comfortable with this. Okay, so the grams would be a unit of mass, obviously. Okay, so in the workbook that you've been given, page 2 has this nice little table, okay? This is for you, Samantha, what I'm about to say next. Samantha, this is for you. If we were going to take a test, physically in the classroom, I would require you to memorize everything in red and blue. I would require it of you. It's silly for me to require it of you online since I can't confirm that you're actually doing it. I can't stop you from looking it up. But, you know, please take my advice. Future nurses, knowing these 10 little conversion factors by memory is going to prevent a lot of heartache for you in the future, okay? So we've got 1, 2, 3, 4, 5 rows of red and 1, 2, 3, 4, 5 rows of blue. It would be really good to commit this to memory. If you commit it to memory and get it in your memory banks forever, life's going to be easier when you come time to do drug dosing calculations and things such as that. So what you have here is a conversion factor table. Let me show you how you read information off of this. Okay, what here on the leftmost column, we're saying that a billion of something, right? 1 followed by 9 zeros is abbreviated by an abbreviation known as a capital G. Think about the gigabytes of memory that your computer might have, right? So 1 giga meter, as an example, equals 1 times 10 to the positive 9 meters. 1 gigameters, a billion meters, a gigameter equals 1 times 10 to the 9th meters. Okay, thousands represented by the abbreviation lowercase k. 1 kilometer equals 1,000 meters, so on and so forth. Okay, down here are some of the units that I'm tickling you with in microbiology. Notice that up here I have billion, and on the other side I have billionth with a th on the end. So 1 nanometer equals 1 times 10 to the minus 9 meters. 1 nanometer equals 1 times 10 to the minus 9 meters, okay? So this is how you read this table. And if you memorize these conversion factors, okay, if you memorize the conversion factors, life will go simple. If it's not clear what the conversion factor is, let me highlight it for you at this time. Okay, hold on here. Come on, technology. All right. So right here, these are the conversion factors. Okay, what I mean is 1 gigameter equals 1 times 10 to the positive 9 meter. That's a conversion factor. It's a ratio. It's a fraction that compares 1 gigameter as being equivalent to a billion, 1 times 10 to the positive 9th meters. Okay, I have much of this logic explained down here for you. Let's go over this. The base unit for length is meter. The base unit for mass is gram. The base unit for volume is liter. And in our course, that's basically what I'm going to stick with. If you get into chemistry, you'll get into molar calculations and things like that. I'm not going to touch that in microbiology, although it would be appropriate. We're going to keep it as simple as possible. Okay, in the table above, number 2 here, in the table above, the word meter is interchangeable with gram and liter. For example, 1 millimeter is 0.001 meters, and 1 milligram is 0.001 grams, and 1 milliliter is 0.001 liters. Okay, so what I'm saying is, everywhere up here where you see the word meter, you could substitute the word gram or liter. Wherever there the word meter is, you could substitute liter or gram and you would have correct information. In other words, I could say 1 gigaliter equals 1 times 10 to the positive 9th liter, and I would be correct. Okay?
So I have a question quick, if that's okay.
Yeah.
So when we put it into our calculator, when we use the scientific notation button, we're just using the exponent that we would see on the end of the 10. Is that correct?
Basically, yes.
Because we're not entering the 10 in there. Like when we were doing the examples, like 1E3,
Yes.
we
And
got 1,000, and that it looks like the exponents are like going down by 3s. So.
And so, Rachel, you have a good observation there. On your calculator, the computer programmers that wrote the software for the calculator told the computer in your calculator to say, hey, every time Rachel hits that scientific notation key, the computer is going to know that the number you put in will be the exponent that you raise the power of 10 to. Did that make sense?
Yes, that's what I thought. I just wanted to make sure that that's what I was thinking.
You are correct. You are correct. I want to encourage all of you to get very comfortable with your scientific notation key. And because I have seen students try to accomplish things alternative ways, and it almost always ends up in disaster. So please get comfortable with the scientific notation key. And if you're not comfortable with it, come talk to me so we can get you comfortable with it. Okay. All right. So, all right. I will point out over here on the left side of the table that I also have these statements, right? Everything in red is actually larger than the base unit. Everything in blue is going to be smaller than the base unit. Okay. All right. So you notice that 1 decimeter is a fractional part of a meter, 0.1, a tenth of a meter, whereas 1 decameter equals 10 meters. So where the red is larger than the base and the blue is smaller than the base. Okay. All right. So everything that's highlighted in red is the conversion factors. And, point number 3 down here, the phrase 1 millimeter equals 0.001 meters is a conversion factor that can be expressed as a fraction or a ratio, right? 1 millimeter is relative to 0.001. These are equivalent things expressed in different units. That's all a conversion factor is. Conversion factors are fractions that allow you to change units during a calculation. Okay? Please make an attempt to memorize things that are color-coded red and blue. It will make your future life easier. Okay, any questions so far? All right, this third page that I've given you, once again, the whole purpose of it is to get those that haven't worked with this stuff in a long time comfortable, right? Over here we have the decimal value, which is equal to the fractional value. Okay, let's highlight 1,000 as an example. 1,000 is equal to 1,000 over 1 in fraction form, which is equal to the scientific notation value of 1 times 10 to the positive 3, which is equal to the phrase 1,000 in the English language. Okay, these are all equivalent things. Now, when it comes time for you folks to do work on an exam, I mean, I get what it means to be a student, okay? You really only care what's going to get you credit to pass the course, right? That's really all you care about. But as a teacher, I want you to know more than that, okay? At any rate, when you're asked to do calculations on an exam, if you put a number into your calculator and the answer comes back in a different format of a number, let's say you put in 1,000 in your calculator and it spits out an answer in scientific notation, you can write your answer in scientific notation. I'm not going to take off for that because scientific notation is every bit as valid as the decimal value. These are all equivalent. So what I'm saying is don't build any anxiety, fear, or stress in yourself. If you put a number in a calculator and it comes out in a different format of a number, you can answer that. You can use that formatted number out of your calculator directly as an answer on your exam. And as long as it's actually a correct value, I will give you credit. What I'm saying is you do not have to worry about taking the answer of the calculator and switching it back to a different number format. You don't have to worry about that. I don't care about that. It doesn't mean anything to me. Okay. All right. Let me see. So Afala Shadi is asking, what if I put in a fraction instead of a decimal? Well, Afala Shadi, if your calculator allows you to put a fraction in and it spits a fraction back out, as long as that fractional answer happens to be an equivalent correct answer, then that's valid, that's correct, and you will get credit for it, okay? So the point of it is get comfortable with your calculator. Don't worry too much about what the format of the answers coming out of your device is, because, you know, 1,000 is equal to 1,000 over 1 is equal to 1 times 10 to the third power. They are all the same thing written differently. Okay. All right. So this page 4 here is an example of how to do unit conversions. Okay, I'm going to let you look at that on your own private study time. Here are homework assignments on the next page, and we're going to start doing some problems here together. I'm going to do them with you online right now, but the point of it is that I want you to practice these conversions on your own time. And, you know, for example, number 1, try to convert 61.65 milliliters to microliters. I provide the correct answer so you can check yourself. And your assignment, your homework is to do as many of these problems as it takes for you to become comfortable with the unit conversion process. For some of you, that might be 5 problems. And because you've had it in chemistry already, you're feeling good. That's great. You're done. For some of you, you've never had this before. You might want to do literally all 25 problems on this sheet to get comfortable with it. So everybody's at a different place with their knowledge and education, but your assignment is to practice these until you are competent in getting correct answers. So let's do this together. Let's practice some unit conversions together. Okay, let's do that. So I'm going to bring up the Word document here, and we'll do some practice questions. Okay. I think what I'll do is, okay. All right. I'm going to ask you to, you know, take your own notes at home and follow along. This is definitely a process that's better if you write it out. Afala Shadi is asking, are we turning in this assignment or is it just for practice? You are not turning this assignment in, but it will be heavily tested on exam 2. So if you don't actually do it, you will not pass exam 2. Okay. All right, let's continue here. All right, so let's do this. All right. Let me pick a color here. I'll pick a nice blue color. Okay, so let's do this. Let's convert 5 feet into inches. Okay, so we'll start with something that that you're used to, okay? So the first thing that we need to do is figure out what the conversion factor is. So conversion factor. Okay, so here's the deal. What is the relationship between feet and inches? Go ahead and type into the chat window, okay? 1 foot is equal to how many inches? 1 foot is equal to how many inches? Type that into the chat window. Okay, thanks so much. Folks, that is the conversion factor. So the conversion factor here is this relationship. 1 foot is equivalent to 12 inches. Okay, this is the conversion factor. Once you have that, everything else falls into place. Everything else is really simple, okay? So here's what we're going to do. All right. Okay, so we're going to start with 5 feet. That's what we stated in the problem. And I'm going to multiply it by my conversion factor. Okay. Now, the thing of it is, I got to be sure that the position of my units in the conversion factor makes sense. So over here with the 5 feet, notice 5 feet is really in the numerator of the fraction, right? That's 5 feet over 1, right? 5 feet over 1. So to convert units, you need to have the same unit opposite each other on the diagonal. For example, I'm going to put here feet, or, you know, the English singular and plural doesn't matter. Okay, I'm going to put 1 foot is equivalent to 12 inches. Notice that the unit I'm trying to get rid of has the same unit on the diagonal, right? Starting top left, going diagonally to bottom right on the diagonal. Okay, if I do that, I'm going to get 60 inches as an answer. Okay. All right, question in the chat window for you. Did this first example make sense? Are you okay? Folks, all I'm going to do on an exam is ask this kind of question, but I'm going to ask it with metric units, and I'm going to ask it with very large and very small numbers that you must rely on your scientific notation key on the calculator to do things. So please don't fight me on this. What I'm saying is, don't fight me. Go to the dark side and actually do what your instructor is asking you to do, and things will go much better, okay? Things will go much better. All right. All right, so let's do this here. Let me see. Let me take a look at my notes for a second here. All right, let's do this. Okay, problem number 2. Problem number 2. Okay, let's do this. Well, okay, so this is problem number 1. Solution 1. Let's do problem number 1 differently. Here's a different way that I could have come up with the same answer. All right, 5 feet times, I could have made my conversion factor this way. I could have put 1 inch here. I could have put 1 inch here. Question in the chat window. Question in the chat window. Okay, with the second, with solution 2, with solution 2, what number belongs in the denominator of the conversion factor? You need to convert 1 inch into feet. You need to convert 1 inch into feet. So what should be in the bottom? So okay. Yes. Okay, so I see everybody there. Okay, right. I see what everybody's answers is in the chat window. Okay, so the broader issue is this. How many feet? Sorry, trying to write too fast with these digital pens just doesn't work. How many feet are in 1 inch? Isn't the answer 1/12? Isn't the answer 1/12? Which I know all of you, or at least some of you, converted 1/12 in your calculator at home when you typed in the answer, right? But the point of it is, to answer this correctly, you would have to put in a compound fraction. And when you do the math on this, you always multiply by the reciprocal. Okay, you're going to get the same answer. Go ahead, okay, in your calculator, take 5 feet and divide by, what was it, 0.083? Yeah, 5 by 0.083. Let's do that together. 5 divided by 0.083, we should come up with roughly 60. That's right, okay? So there's 2 different ways you could write the conversion factor, okay? 2 different ways you could write the conversion factor. So this conversion factor is the same thing as this, okay? 1/12 of a foot is 1 inch. Same thing, okay? Now let me ask you a question in the chat window. Do you feel more comfortable doing solution 1 or doing solution 2? Is there anybody amongst us that say, I love solution 2, that's the best way to go? Okay, and nobody likes it, right? Nobody likes it because the logic is a little bit harder, right? The logic is a little bit harder. Folks, here's the intuition. Here's the intuition. You know from the life you have led that 1 foot, you know because of your life's experience that a foot is larger than an inch. How do you know that? Because you have lived it. You have lived it. So when I ask you, well, how many feet are in an inch? That seems kind of crazy, doesn't it? But we can still logically reason it. Doesn't it make sense for this one down here? Doesn't it make sense that a piece, 1/12, a piece of a large object like a foot equals 1 of a small object? Okay. So a foot is larger than an inch. You intuitively know that because you've lived that experience your entire life. When we flip it on its head, it feels uncomfortable. But doesn't it make sense that a piece, a fractional part of a larger object like a foot, a piece of the foot, is going to be equal to one of a small object? Does that inverted logic make sense to you? Does the inverted logic make sense to you if you think about it? Give me some feedback in the chat window. Okay. Here's the deal. You all told me you preferred solution one, and I understand that. The problem that students run into in unit conversion problems is that there will be moments when you're doing the work where the kind of uncomfortable logic of solution two comes into play. And if you're not careful, you actually write your conversion factor upside down and foul yourself up. That's why you need to practice this so that you develop a level of comfort with it so you're not thrown for a loop on the exam. Okay? Let's do a harder one together. Let's do a harder one together. Okay, so let's do it another one here. Okay, this will be practice question number 2. Okay, let's do practice question number 2. Feel free if you have a question to chime in here. We're going to do question number 2 at this time. All right, and so I'm going to pick a problem off your workbook. I'm going to pick a problem off the workbook. Okay. All right, let's do problem number 3, which is this. The problem in your workbook on page 5 of your workbook says take 525.4 milliliters and convert it to an equivalent amount of kiloliters. Okay, so here's how we do this, folks. I'm going to ask you to help me along the way. Okay, so if you have the workbook available on your computer, if you've opened it up as a PDF document, that will be helpful. All right, so 525.4 milliliters times. Okay, so I need a conversion factor. Okay, conversion factor. Okay, so all right, let me just see how we're doing here. Alicia Goss. Alicia, would you please unmute your microphone and say hi to us?
Hello.
Hi, Alicia. How you doing?
Good.
Okay. So, Alicia, are you able to look at the workbook on your computer?
I have it printed out.
You have it printed out? Okay.
Yeah.
That's even better. Okay. So everybody flash up page 2 in your workbook. Okay. This one right here. Oh, excuse me. What am I saying here? Yeah, page 2. Okay. That's what I want you to look at. Now I need to go back to my Microsoft Word document. And so, Alicia, on page 2, do you see anywhere where the table tells you how to go directly from a milliliter to a kiloliter?
No.
No. Okay, that presents a problem, doesn't it? Okay. In other words, your table that I'm asking you to memorize does not tell you, it does not give you a conversion factor that allows you to directly go from a milliliter to a kiloliter. So Alicia, stay with me. Here's what I want to do. When you have a problem where you do not obviously know what the conversion factor is, here's what you should do. you should go through the base unit first. So Alicia, I want to go from milliliters to what?
To liters.
Good, nicely done. So I'm going to put milliliters on the bottom, and I'm going to put liters on top. Okay, so Alicia, with table 2 open, please tell me what numbers you want me to put down in this fraction.
One liter is equal to 0.001 milliliters.
Okay, so you're telling me to do this. Have I written down what you wanted properly, Alicia? Have I done that?
Yeah.
Okay. All right. So I see our time together, and I'm going to ask and beg you to give me maybe another 10 minutes of time. Hey, thanks, Alicia. I appreciate it. Let me ask this in the chat window. Do you agree with Alicia's numbers for the conversion factor? Okay, so Alicia, don't take offense because we're all here to learn, but it seems like quite a few folks don't agree. So Aubriana, what do you think I should do? Aubriana, what do you think I should do?
For the milliliters, I don't know.
Okay. I'll let you off the hot seat, Aubriana, but you know, this is one reason we need to practice this. Okay, Fatimata, what do you think we should do? Fatimata, you okay?
Yes, I was just thinking, she got the right number is 0.001. 1 millimeter equals to 0.001 meter.
Okay, so tell me how I should change the information on the screen. What should I do? Okay, I'm going to move forward because we're short on time, but I want to use this as evidence that what I'm asking you to do is not as simple as you might think, which is why you do need to practice this. Okay, so here's what I would do. Okay, so let me just say first that this is not correct because the table was read upside down, so to speak. Okay, what you should do is this. Okay, 525.4 milliliters times liters and milliliters here. Okay, let me check the chat window here. Okay, so, you know, if you look carefully on the table, go down to the color-coded section that's blue, and do you notice that the third row of blue there, where it says thousandth, it says 1 millimeter, or in this case, 1 milliliter equals 0.001 liters. So I would do this, 1 and 0.001. Okay. Now, if I do the calculation, my answer is going to be in liters, and that's not where I need to be. I need to be in kiloliters. So what I will do is cross off the units that I can, and I will continue my calculation. So now I need to go from liters to kiloliters. So liters will be on the bottom. Kiloliters will be on top. And again, you read your unit conversion table here. And notice if we go back up into the reddish pink area, it says 1 kilometer, 1 kiloliter equals 1,000 liters. So it's this situation, 1 by 1,000. And that will allow me to cross off liters and then do the work. Okay, so to do this work, here's my recommendation to you. Where I see students get into problems is that you try to do everything in your calculator at once. And if you're not very careful with that, you end up with the wrong result. So what you should do is multiply everything on top. And write that answer down. Multiply everything on the bottom. And write that answer down. So let's do that. Okay, I'm going to do it with you here. 525.4 times 0.001. That's 0.5254. Then I'm going to multiply everything on the bottom. 1 times 1,000 is obviously 1,000. Then I'm going to divide the top number by the bottom number. Sorry, that's a little bit ugly. So 0.5254 divided by 1,000 equals this answer of 0.0005254. And you ask yourself, is that what the correct answer is that's published in your workbook? Is that the same number? Turns out that it is, right? All right. Okay.
I got the scientific notation of 5.254 10 to the negative 4.
Yep, that's okay. That's okay.
That just confuses me because when I look at that, I'm like, what?
Right. So thank you for asking that, Elena. And my point that I said earlier stands. If your calculator does that and gives the answer in a different format of the number, as long as it is actually correct, you will get credit on the test. So if you wrote that down, Elena, on a test, I would give you complete credit for it. Okay.
Now, when we write it down on a test, would you be okay with us writing the E, or do you need us to write down times 10 to the negative 4th?
I would prefer times 10 to the negative 4th.
Okay.
Okay. Other questions? Okay. So folks, I'm going to stop sharing my screen. We made it through the math stuff. I didn't get to do any more chapter 8 today. That's okay. I'll pick back up on Thursday. But once again, I'm going to stop recording.